Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day in my virtual classroom. Step on inside. We are going to be doing a little review on something of some older videos of mine. It has to do with you if you're getting kind of an intro to solving algebraic equations and doing things with algebraic expressions. Very, very basic setup as far as order of operations, substituting values, combining like terms, distributive property, and then solving two-step equations or something very small within that. You might have to distribute or something along the way. I think 10 problems in total with this thing. Should be relatively fast. If you've gotten your little intro in algebra stuff, just hearing what I say should mostly make sense of what's going on. And sorry for having an epileptic seizure, from this little commercial here. I got some baseball going on in the background. Hopefully at some point we can see that happen. All right, guys, let me show you what worksheet I'm going with here. Now, if you want to find this worksheet, you can see it down below in the description section as a PDF, which you can download. And I will go ahead and let you do that. All right, so for this practice quiz for my kiddos here, they got 10 questions. Let me show you what they look like. We got an order of operations problem, try and evaluate that. We have substitution and evaluation through, you guessed it, order of operations. I have 4 expressions which we have to simplify, which means distribute, combine like terms. And then we have 4 equations for which we're attempting to solve for the variable x, p, n, and x. And that's it. So let's take a look at what we have here, starting with number 1 and 2. When evaluating each expression here, we have to follow the order of operations, which is parentheses first, exponent second, multiplication and division next, addition and subtraction last. If something's on the same level, we operate left to right, which means right here on number 1, we have a set of parentheses right here, which means we should operate within those first before we do any multiplication with this. I know that addition and subtraction go after multiplication, but things inside parentheses go before multiplication. So when we look at number 1 here, we have -2 minus 8 plus 7. Now addition does not go before subtraction. Just because addition's written before it doesn't, addition and subtraction are on the same level. So what we do is we operate left to right in this case. We start with -2 minus 8, and that's going to be -10. And then there's the plus 7 that's going to occur. That's still within parentheses. So I'm just going to go one step at a time on these. -10 plus 7 is next because we're still within parentheses. -10 plus 7 is -3. So that's going to be -3 times 8. Do the parentheses matter at this point? Maybe not. But -3 times 8 here is indeed -24. So that's what we're going to be getting here. That is your end result. And that is number 1, following the order of operations. Number 2. In number 2, we have this expression right here, y times the quantity y plus x, and then plus x and minus z. Now we have things that we are going to be substituting for each of these variables. Now I have a mantra for my students which goes as follows. When you're substituting, when in doubt, use your damn parentheses. And what that means is, when you substitute, parentheses really do have this ideal nature of following the order for which we are supposed to be doing things. Not just order of operations, but I mean, you won't have 2 operations in a row. When you have a coefficient next to a variable, that substitution makes it multiplication as it's supposed to be. A lot of things like that really do help to use parentheses when you're supposed to. Now, you don't have to use them all the time. If you are not sure whether or not you should, you probably should anyway, just in case there's a bit of overkill. So let me kind of show you what I mean here. I'm going to substitute 3 for y right here. Now I could use parentheses around that 3, and I'm going to just because I have doubt. I don't really know whether or not I should. Now I have a parenthesis right here, and I have this y right here, which I also have to substitute another 3. And then plus x, so plus -3, and then close that parenthesis right there, and then plus another -3 minus z, which is -9. Now this really does help because what parentheses also do is they indicate me saying this is what's going in for that variable. And this is important because when you see this minus z and z is -9, I know that this minus is here and the -9 still exists from z because I wrap z's value around parentheses. That's kind of nice. Now, which parentheses really don't matter as much? I would say the ones with y. So right here, I would say this one is irrelevant, as in if I remove it, it has no effect on the problem whatsoever. Let me kind of get the 3 back in there. And then the one around this y as well. Okay, I'd say that those had no sort of bearing on it. They were positive numbers. They weren't a variable with a coefficient next to them. there's just no harm, no foul on those ones. The other ones, operation next to operation, get parentheses around it. Operation next, things like that. So I think these ones were more important. All right, now order of operations do come into play. We operate within parentheses first, but there's nothing to operate within this set of parentheses, except the two operations with each other. So all I'm going to write on this next step is I'm going to rewrite the plus negative into a minus, the plus negative into a minus, and the minus negative into a plus. So I'll have 3 times the quantity here, 3 minus 3, and then I have plus negative 3 turns into minus 3, and minus negative 9 turns into plus 9. So showing this work kind of does help you keep things in order and make it nice and clean as you go from step to step. Now I'm going to work within the parentheses here. I have 3 minus 3, which becomes 0. I'm going to do 3 times 0 there. Now there is a minus 3 plus 9. I could ideally do those right now, but for the sake of just working left to right, I'm going to clean this up first, this 3 minus 0, or 3 times 0 I should say. 3 times 0 is 0, so that goes away. We get 0 minus 3 plus 9. 0 minus 3 is negative 3, and negative 3 plus 9 is 6. That's a lot more steps than you probably need. I'm kind of just, really breaking it down, making sure that you get all the little inlets of what I'm doing from each problem, or each part, in case you're writing it down. So you can choose which parts you think are relevant and which parts you can do at the same time. For example, I could have done negative 3 plus 9 and turned this into 6 a long time ago while I was doing 3 times 0 right there, because these are not affected by this in any sort of way except for what these just combine to be through multiplication. So there are times that if you know that you can do that, go ahead and do that. But if you're not sure, I would just work left to right and use order of operations whenever possible. Anyway, those are our 2 order of operations problems. We're good from there. Let's move on to numbers 3 through 6. And on these problems here, when they say simplify each expression, again, we're trying to do 2 different things here. Number 1, make sure there are no parentheses in the end by distributing things that you can. And number 2, combine like terms where you possibly can. Like terms are terms that end in the same variable. If you get into deeper math, we'll say with the same degree, like I can't add x squared with x, but we're not dealing with x squareds or anything right now. So things with the same variable can add, constants can add together, things like that. Now, one thing that can help you with these on a problem like number 3 is sometimes people prefer to rewrite their expressions, their terms, I should say, in their expression in an order so that terms of the same variable are next to each other and constants are next to each other, things like that. So what if I rewrote this instead? I'll write all 4 terms, but I'll have 6x, and I'm going to put the other x term right next to it. Positive 3x will be right next to this guy. It just helps. And I'm not saying I'm going to do this every time. I'm not saying I generally do this, but this is a good technique for those who need the alternative. So I've used those 2 terms. Now I have a plus 8 and a minus 2 right there. So I've used all 4 terms. I rewrote them. This helps me identify which terms need to combine. I make sure to know which sign follows with it, and it kind of makes me avoid making some mistakes. So 6x plus 3x, basically you keep the x and you add the coefficients together, 6 and 3. That gives you 9x. 6x is added together plus 3x is added together is 9x is added together. That's the idea. 8 minus 2, positive 8 minus 2 is going to be 6. So that's going to be plus 6 right there. So that's the expression. I'm not solving for x, guys. This is an expression. It's not an equation. I'm just cleaning this up a little bit more. Basically, this original expression and this expression are equivalent. If I did substitute a number for x, like 100 or anything like that, I'm going to get the same value out here as I would here. It's the same expression but simplified. All right, number 4. Negative 3 times the quantity n plus 2. Now this is a quantity where there's nothing. If we want to talk about order of operations, we would say do things inside parentheses first. But there's nothing that we can combine inside these parentheses. We have n plus 2, unlike terms, we got to leave them separate. So what do we do to simplify? Well, the end goal, like I said, is we want to distribute out these terms in a way that there are no parentheses in the end. That allows us to do things like combine like terms if we could with other terms. But looks like these are the only 2 terms that exist. So let's just distribute. The negative 3 is multiplying with an n and a 2, which are both positive. Negative 3 needs to multiply with n. Negative 3 needs to multiply with 2. And the 2 results will add together. So I'm going to have negative 3 times n plus negative 3 times 2. And when I say plus negative, it just becomes a minus. Negative 3 times n becomes negative 3n. That is the equivalent of writing that there. Negative 3 times 2 is negative 6. The thing you have to be careful with these things is make sure you are distributing that negative here. Sometimes people only do it the first time, and then they kind of forget the next time. They just see the 3, and then they do nothing else with it. So make sure that you are bringing that over. This is a simplified version of what's there. And again, simplified means we didn't solve. We just gave a rewrite of this thing so that these are equivalent. I could plug in something for n, and I would get the same thing here as I would here. It's just a different version of it that, again, by rules of simplification, we accomplish something, which is awesome. All right, number 5. Negative 2 plus 4 times the quantity a minus 3. Now here's what we don't do. We do not do negative 2 plus 4 first and turn this into 2 times a minus 3. No, 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 no. Order of operations says that we, well, parentheses first, but we do multiplication before addition. So the only way that I could possibly add these two together through addition is if for some reason these were in parentheses on their own, but they're not. So although you have addition right here, don't add these two, we must multiply first. Mr. Robinson, where do you see multiplication? Well, the parentheses, let me change color now. The parentheses right here with a 4 right next to it is saying the 4 is multiplying with these, just like the negative 3 was right here. So this 4 is multiplying with the a minus 3. I must first distribute. I must first multiply the 4 into the a and into the negative 3. The negative 2 is still a part of this expression. I'm going to rewrite this with the negative 2 here. I'm going to be adding 4 times a and 4 times, careful, negative 3 there. Okay, so this becomes negative 2 plus 4 times a is 4a plus negative 12. That becomes minus 12. So you can see what distribution allows us to do. Now we have an expression where we actually do have two like terms, this constant here and this constant here, for which we can combine. We couldn't combine before because this negative 3 was stuck in a set of parentheses being multiplied by a 4 that we didn't yet unleash. We didn't untap its potential, or we tap into its potential, I should say. It has untapped potential. So we can now combine the negative 2 and the negative 12. And I'm not going to reorder the terms, but we are going to do negative 2 minus 12. And together, guys, that does give you a negative 14. And right here, we still got a nice little 4a that can come and play. It doesn't combine with anything, but it's still a part of the expression. And these are the combined like terms after distribution. That is the simplification. That is the simplification of that expression. Again, equivalent to this one here. In number 6, the last expression to simplify here, I must distribute the negative 4 into the 5x plus 5. And I must distribute the 6 into the x plus 2. As nothing could combine within the parentheses here, I go straight into the distribution tactics. Now, negative 4 multiplies, it's a negative 4 that multiplies with both 5x and 5. Let's do it without writing like this in-between step of the multiplication. Let's just do it. Negative 4 times 5x is negative 20x. Negative 4 times 5 is negative 20. Notice one has an x, one does not. These do not combine because of the x term here and the constant here. Now 6, this is a plus 6, a positive 6 that multiplies with x, so plus 6x, and a positive 6 times positive 2. That's positive 12. So after distribution, we now have a set of no parentheses. So now we can find like terms which we could possibly combine and then rewrite this expression, keeping that in mind. So negative 20x can combine with 6x because they are both terms with x in it. And when you combine those two, negative 20 plus 6 is negative 14. So we're left with negative 14x. Now, negative 20, remember, there is a negative with the 20 that we have to use. This belongs with this. Negative 20 combines with positive 12, as those are both constants right there. And again, I'm not reordering the terms, but I'm drawing where they go. And that end result there, negative 20 plus 12, is negative 8. I'm not shying away from my own students even using a calculator if need be, but as long as they show the steps in between, then I'm set there. And, you should probably be as well. But at some point, you really want to feel comfortable being able to work with negatives and positives through addition. All right, so those are those ones, guys. Simplifying expressions. I got 4 more problems to do in terms of solving equations. I don't know if I'm going to double check them all by writing them out, but I will show you the idea of what you do to double check and make sure that you are correct in your answers. So let's see what goes on. In terms of solving an equation, now that it has an equal sign, our goal is to isolate the x variable, trying to get x by itself, by using what are called inverse operations. Okay, inverse operations on terms in order to again, get that x by itself there. So we have negative 1 plus 2 times x equals 21. In order to get x by itself, we have to apply inverses to the negative 1, which adds with the 2x, and then the 2 that's multiplying with the x right here. If there is a negative 1 here, and I don't want it on this side anymore, I'm going to have to make this thing become 0 by actually adding 1 right here. But I can't just add 1 on one side and make the equation imbalanced. I have to keep the balance. If I add 1 on this side of the equation, I must add 1 on this side of the equation. That is a balance idea. Negative 1 plus 1 is 0. That goes away. I'm left with just a 2x right here. And 21 plus 1 is 22. Okay. Now we get to say 2 times x is 22. What is the number that we would need here to make 22? If something times 2 is 22, we divide 22 by 2 to figure out what it is. Let's divide both sides by 2 here to find out what just that single 1x is. What is 1x going to give us there? 2 divided by 2 is 1. That's what we want to make that kind of cancel out. We're left with x here. And 22 divided by 2 is 11. That is the value of x that ideally makes the original equation a true statement. Now, I will show you a double check on this one as far as what you can do to say, was I right? Was I correct? Like, not me, but you just asking yourself when you do a problem. Was I right? Was I correct? You know, what happens? So if you look at the original equation here, we can do a substitution, and remember, when in doubt, use your damn parentheses. You can do a substitution here and substitute 11 in for x into this equation. Negative 1 plus 2 times 11 equals 21. And just simplify this left side and see if it actually turns into 21 like you anticipate. 2 times 11 is 22, so we get negative 1 plus 22 equals 21. Negative 1 plus 22, that's the same as 22 minus 1, that gives you 21. 21 equals 21. Hey, that checks out. That does indeed seem to be the case that left side equals the right side, therefore x equals 11 was correct. So the work we did panned out. I'm not going to double check in that way for the other problems, but I might be able to mentally say it with you. So, okay, that is number 7. Let's look at number 8. On number 8, we have negative 7 plus p, all divided by 6 equals 2. Kind of an interesting thing here because I'm not going to do number 10 just yet, but if you take a look at number 10 alongside, you know, the idea with number 8 here, they both use division, but in number 10, there's just a fraction with just the x variable, and here it's a fraction with both the variable and the constant with it, which just goes to show that the division is taking place at a different time on these things. First, negative 7 adds with p, and then that result gets divided by 6, whereas here, first the x gets divided by 4, and then the 7 here is subtracted from it. So, you know, you can see that it's kind of a different order. So in here, dividing by 6 happens last in order to get to 2. So basically, I'm dividing a number by 6 to get 2, and I want to find out what that number is. This isn't p necessarily, but this is, I'm dividing something by 6 to get 2, and I want to find out what the number is. That goes to show that you do end up multiplying by 6 first to figure out what it is. If I want to figure out what the whole variable is, I got to first multiply both sides by 6 like this. This gives you a 6 divided by 6, which, hey, can go away. That's 1, and I'm just left with the numerator here. I have negative 7 plus p. Now, on the right side, I happen to multiply this by 6 as well, and I get 12. Remember, we said something divided by 6 is 2? That number is 12. 12 divided by 6 is 2. So apparently, when I divided this thing by 6 to get 2, this thing must be 12. So yeah, this is 12. So what is p? We still have the negative 7 to deal with, just like this negative 1 before, right? So we're one step away. Let's add 7 to both sides. Because the 7 was negative, I must add 7 to make it 0. So I add 7 to the other side. Again, balance. Negative 7 plus 7 is 0. I'm left with p. And 12 plus 7 is 19. So p equals 19. I'm set to jet. Boom, full solution. If you'd like to double check it, here's what you do. Look at the original equation. And you would have negative 7 plus 19. Negative 7 plus 19 is 12. And 12 divided by 6 is 2. 2 equals 2. It checks out. We're good. All right, 2 more questions here. I'm hitting the 20-minute mark, so I'd like to get through. Number 9, 3 times negative 2 plus n equals negative 63. Now, there are 2 ways that you can do this problem. As far as my students go strategically, I would really just look at one direction on this thing and not the other, just because you might not notice the strategy. But I'll show you guys both strategies. First, I'll show you the more logical one that you're likely to come up with, which is we begin with distribution. You see something, an expression on the left side, and you're normally tasked with simplifying the left side before and the right side before you move terms over. All right, let's start with distribution. 3 will multiply with negative 2. 3 will multiply with n. Okay, so 3 times negative 2 is negative 6. And then 3 times n is 3n. So we get negative 6 plus 3n there. Okay. Now that equals negative 63, as I haven't changed anything on this side. I just simplified the left side. Now I'm at basically a two-step equation here. I just did the distribution. Now I'm 2 steps away from solving. This is very, very, very much like what you're seeing on a problem like this one here, number 7. So I must first, to get the n term by itself, let's first add 6 to both sides, get that thing over. Negative 6 plus 6 is 0, and we're just left with 3n right here. 3 times n. Negative 63 plus 6, it's not negative 69, it's negative 57. So we're getting closer to 0 there, negative 57. Hey, take your calculators out as we divide both sides by 3 to just get that n variable completely by itself. Negative 57 divided by 3 is negative 19. 57 over 3 is 19, and a negative divided by a positive is a negative. So n equals negative 19. There's the final result. A good double checking could take place if you substitute back in. See what you get there, but it should pan out. Now that's one way to go about doing this problem. What I say, I'll say I marked in green. Give me 1 second. Let me lock that thing in. All right, the second way that you can do this, which I'll indicate using purple here, is instead of distributing to start with, you have to remember, you might remember that 3 is multiplying by this, but that doesn't necessarily mean that you must multiply by it. Remember, the goal is to get this variable by itself. If something's multiplying by the variable, and remember, technically 3 is, but it's also multiplying by negative 2. If something's multiplying by it, then that means you can still divide it out if you want to move it over, right? We divided by 3 at the end, but could you divide by 3 at the beginning? Technically, yeah. This kind of falls in play like number 8. Remember, 6 is the last thing that was divided here. 3 is kind of the last thing to multiply. Negative 2 gets added with n, and then the whole thing gets multiplied by 3. So you could divide by 3 to start with if you wanted to. Divided by 3, divided by 3. And then 3 over 3 becomes 1. It's gone. And as long as this number can divide by 3 right here and you don't get a fraction, then it's an okay go. You know, it's something that you can actually work with. So, and it does work. This becomes negative 21. So negative 2 plus n, all that remains on this left side now, equals, on this side, negative 21. Now you add 2 to both sides here to get that n by itself, because again, of course, the negative, and then you are left with n equals negative 19. So same answer, different approach. Again, I don't suggest that a lot of my students would necessarily see that and work toward it, especially if you get into a fraction here. And I'm not anticipating I'm going to give you a problem that would lend to a fraction like that, so just kind of be aware. Okay, number 10, very last one here, and then I'm done. I want to make sure I get this within 25 minutes. I can do it. I've got 2 minutes left. Negative 6 equals x divided by 4 minus 7. Now, the minus 7 occurs last as far as what happens in this expression, which means let's deal with it and get rid of it first in order to get the x variable by itself. Let's add 7 to both sides because it's negative, and therefore I have to do it to both sides here. Negative 7 plus 7 is 0. So I'm just left with x over 4 here. Now, don't get too turned away with the fact that you do have a fraction. That just means we're going to be doing the inverse, which is multiplication. Negative 6 plus 7 is 1. So 1 equals x divided by 4. Something divided by 4 is 1. What is that number? Let's multiply both sides by 4 to figure it out. All right. So we have 4 divided by 4 there. That's gone. And 4 times 1 right here, which is 4. 4 equals x, or better written for me as x equals 4. Oh, you can't even see that, my bad. X equals 4 there. And again, a double check. 4 divided by 4 is 1. 1 minus 7 is negative 6. That equals that. That's good. All right, so that's my review for this one right here, guys. I know that these can get a little complex based on the problem here. These are just a few of them to look at. There's a wide array of them, but that's why when I teach these things, I want to make sure to say out loud every single thing I'm attacking, how I'm going about it, and what you can do in alternative ways, how you can double check. So again, order of operations, PEMDAS. When in doubt, use your damn parentheses. When combining like terms, you might want to reorder your terms just in case, and so you can combine things with variables and with constants and things like that. When you distribute, be very cautious of that negative. Maybe have this step in between to show what you're multiplying, just to be aware of it. And simplifying in general means no parentheses and combine like terms there. And then solving equations, again, do what you can to isolate the variable by applying inverse operations. If you see a plus, use a minus to move it over and cancel it. If you see multiplication, use division to move it over and cancel it. Things like that, vice versa. All right, that ought to do it for me here, guys. This is Mr. Robinson. Thank you so much for watching. I sure hope this was helpful for you. Leave questions down below if you have any. Take care.